Unit 10 Vocabulary. Angle. A figure formed by two rays with a shared endpoint called the vertex. So we have an angle here, our vertex, and two rays. You can see this angle as angle B, or we could see this angle as angle ABC, or angle CBA, as long as the vertex is in the middle. Right angle is an angle that measures 90 degrees. Often we'll see a box drawn to show that it is a 90-degree or right angle. Acute angle, an angle that measures less than 90 degrees. Obtuse angle, an angle that measures more than 90 degrees. That's greater than a corner, less than a corner. Complementary angles are two angles that have a sum of 90 degrees. So together they would make a right angle. I used to think of changing the C to a 9. So then it's 90 to remind me that together they make 90 degrees. We have an example here, angle 1 and angle 6. It's two angles that together are forming a 90-degree angle. Those are complementary angles. Supplementary angles are two angles that have a sum of 180 degrees. So we can see here, angle 4 and angle 3 together are making a straight line. So together they're making a 180-degree angle. So they are supplementary. And I used to change my S to an 8 and stick a 1 in front of it to remind myself 180. Vertical angles. A pair of equivalent angles formed by intersecting lines. They equal each other. So if I had a line here and I have a line here, notice I have two intersecting straight lines, and the angles across from each other would be equivalent. They would equal each other. They're the same angle measure. Adjacent angles, angles that share a common side and a common vertex. So we could look here, angle 4 and angle 3. They both share that same vertex in the middle, and they're sharing this side here. So they are adjacent angles, adjacent meaning next to, or they're next to each other. Angle 3 and angle 6 would not be adjacent. Although they're sharing this common vertex, angle 3 here and angle 6 here are not sharing a common side. There are several other examples of adjacent angles here, but we'll go over this further later in the week. Polygon. A figure with at least 3 straight lines and angles. A specific polygon is a quadrilateral, a 4-sided figure that has interior angles that add up to 360. You can remind yourself quad means 4. And if you ever forget that it's 360, think of a rectangle or a square. We know that a rectangle or a square has 4 90-degree angles, and 90 times 4 equals 360. So this unit we'll start to look at, we have a quadrilateral here with a missing angle measure, and we can use an equation to solve for that missing measure. Another polygon, we have triangle, a 3-sided figure that has anterior or inside angles that add up to 180. A triangle is half of a rectangle. So if we know a rectangle is 360, then half of that is 180. Again, tri means 3. And we could use this information to find for a missing angle measure. We have 60 and 40, and the angle we don't know all together have to equal 180. And then we can solve for C. Some types of triangles. A right triangle is a triangle with one 90-degree or right angle. A scalene triangle is a triangle where no angles or side measures are equal. So we have line AB has 1 dash, line AC has 2. If they had the same number of dashes, it would indicate that they are the same size. Because they're different, that means this side is not equal to this side, which is not equal to side BC. The same with the angle measures. The tick marks inside, if they are different, that means they are different measures. An isosceles triangle is a triangle where 2 angles and 2 side measures are the same. So we can see side AB and AC are the same length, and the angle measures here are the same measurement. Isosceles, I used to think I have 2 eyes. Well, there are 2 angles and 2 sides the same. Our last triangle is an equilateral triangle. A triangle where all angles and side measures are equal. So an equilateral triangle will always have 60-degree angles, because 60 times 3 would get us that interior angle measure of 180, and our side lengths are always going to be equal. Equilateral triangle.